This video, we are going to be talking about how we can scale an app to go across the entire world. So this is going to build on some of the principles we talked about with horizontal scaling. When you take a server and to grow, you will add multiple servers working together as a single unit. This is the idea of horizontal scaling. But what we didn't talk about is where are these servers located? Or where is the entire collection located? Are they very close together or are they spread out across the world? So let's first talk about when you horizontally scale, how close will those servers be located to one another? Now we're going to talk about a few different options here, but first you might want to check out the previous lesson which talked about horizontal and vertical scaling. That'll give you the foundational information, as well as two other resources, the first being the Backend Engineering Mind Map, and this is a comprehensive overview of everything you might need to be familiar with if you want to become a backend software engineer. Another resource is I have a mentorship program if you want guidance in learning these things and succeeding at technical interviews. Check that out. I'll have links for those below. So if we grow to multiple servers, these could be within the same data center, or they could be in different data centers in the same region. So same data center or same region, diff data center. And what exactly is a region? Well, that's kind of vague, but let's just say it's, a certain amount of distance. You might have a data center in a different region, but we'll say it's still within the same country. So for example, within the US, you might split the US up into multiple regions, and you might have data centers in different regions, but they're all within the United States. And then lastly, we could have servers in completely different countries, and those could be across different continents even. Now, this is the stage you want to get to if you really want to bring your app global. And that is built off of the assumption that the Earth is truly a globe. But we're not going to get into that in this video. But just think about it this way, right? Like, if the Earth was a globe, how would flat shoes work? Wouldn't you have to have shoes that were like slightly curved to match the curvature of the Earth? And come on, guys. All you globe theorists. Why am I even getting into this? So if you're a true believer in the globe Earth theory, then I'm going to need an answer for that question. Otherwise, we're going to get back to it. Now I'm going to change this to continents because that's where the biggest difference comes up, as there are regions that are in different countries but still within the same continent. So you might group those regions as North America regions, for example, and we're going to get into some of that in a few moments. So we're basically looking at it from closest together to most spread out. For this one, they are in different regions, but they're still within the same region set, most likely the same continent. And then lastly, completely different continents. So let's go through each one of these. The first one being the same data center. Now, you can think of a data center just as a building or potentially multiple buildings, but all one location. So there might be a company or a cloud provider that hosts a bunch of stuff from one data center in one location. So if you have multiple servers, let's say we have 2 servers, and they're in the same data center, it might be the case that these are physically located right next to each other. And you can imagine this improves the application somewhat, because if one of the servers breaks, the other one is still there to take traffic. So this helps the service become highly available, and it helps with the scalability because you have 2 servers instead of just 1. This does not help with latency. Because these servers are pretty much right next to each other, it doesn't matter if I make a request to this one or this one, it's going to take roughly the same amount of time. So it does not really impact the performance of the application for any individual request. It does help with the overall performance because it allows us to have more users. Cool, so that is all within the same data center. Now let's talk about within the same region, but different data centers. So for us to understand things being in the same region, we should first understand what a region is. And it's a little vague, and it probably varies from cloud provider to cloud provider. We're going to take a look at AWS as an example here, but the idea is probably very similar for other services out there. So within AWS, you will have a collection of different regions based on continent. So for example, in North America, there are currently 8 regions, and I think a 9th one is coming soon, and that's based on the time of this recording. So these numbers might change in the future, but there's 8 different regions in North America right now. You'll probably want to pick a region that's fairly close to the users of your application. These are all given some name, such as US East 1 or US East 2. There's US West 1, US West 2. So for example, if you're going to be serving a lot of users in California, you probably want to go for one of the West regions compared to the East regions. Now, these are different regions, but for this level of scale, we're talking about different data centers within the same region. So if you just select one of these, obviously we're going to go with US East 2, Ohio represent, let's go. All right, so within here, we're going to have multiple data centers. So there may be many data centers inside of US East 2, but we're going to split those up. So we'll have different availability zones, which are logically separated data centers. So within a region, there are multiple data centers. So these logical groupings, the availability zones, as AWS calls them, will have names like US East 2A, US East 2B, US East 2C. So in this scenario, if we want to go within the same region, but different data centers, we would split up those servers into 2 different availability zones. So now we have a server here and we have a server here. The different availability zones within the same region are physically separated, but set up in such a way that they can communicate between each other very efficiently. So you can imagine we have a group of data centers over here, a group of data centers over here, and then a connection between them for data transfer. There's a good chance they're both not going to be impacted directly from a power outage, but they're still within a fairly close distance and they're set up to communicate quickly. So you are a bit more safe from issues that might impact an entire data center or availability zone. So these guys are set up to be able to communicate efficiently, but they're physically separated, so they're in the same region, diff availability zone. So this is going to improve the high availability, so it's going to be more available than if they're in the same data center because we are removing a single point of failure physically, having just a single location for the servers. So now if there's a power outage, there's a chance the service stays available. It will still help with scalability because we have 2 servers. So that hasn't changed either. In terms of latency, it's probably not going to make a major difference because the servers are so close together that it's not that big of a deal. Like they're both within Ohio. So if you're making a request from California, it doesn't really matter if you hit this server or this server because they're so close together. So the biggest benefit in this step is that you're protecting yourself against issues that might impact a complete availability zone, possibly leaving your service completely unavailable if both of your servers if they are within the same data center or availability zone. So the major benefit you get going to this step is protecting against issues that could impact an entire availability zone. If they were both in the same location, both of the servers, then you could potentially go completely unavailable if something happened to that location. So that is the major benefit you get from having things within the same region, but splitting it out to 2 different availability zones. This is a fairly simple step, so it's not going to add a lot of complexity to your architecture. So I would probably recommend doing this for protecting your high availability. All right, so we go beyond just a single region. We're now ready to go to multiple regions, so we could have servers in different regions. So in this scenario, you can imagine having a server on the west coast of the US and on the east coast of the US, and we somehow need to get these things to work together. In this scenario, you might need to do a little bit more setup than the previous scenario because we want these servers to work together, but there's a good chance we're not just going to evenly load balance across these 2 regions. Let's see how good I can draw the US. pretty flippin' good if you ask me. So let's just say you have a server here and a server over here. And you have people making requests from all over. And maybe even outside of the US. So these are different clients making requests to servers. Now, we probably want to keep in mind their location when we direct them to a certain server. So it probably makes sense for this one to be directed to this server, probably same here, this one maybe here, and this one maybe here. So we don't just want to blindly split the traffic across the two servers, because that gets rid of the major benefit of going multi-region, which is that we can make servers closer to the clients making requests. So instead of just having a load balancer that surrounds both of these, you'll probably use geolocation routing. So this will be at the DNS level, directing based off of the location of the request. So where does load balancing come in then? Most likely you will individually scale these units based off of the amount of traffic in that general region. So let's just say in theory, this is getting 75% of the traffic to your API in this case, and this one's getting 25%. This means we could give a lot more computing resources to this unit over here and less to this one over here. When it comes to load balancing, instead of just thinking of this as a single computer, you can think of it as a single unit or a single service logically. So this might actually consist of multiple computers. So you can imagine it to look something like this, where we actually have 3 servers in this region. This one might consist of just 2 servers. They can be different. So the load balancing is most likely going to happen at this level. So we split the load between these individual servers, and we split the load across these servers. And another thing to keep in mind is that for each one of these, I'm just going to draw some arrows here because I'm running out of space. These could be in different availability zones. So within the same region, but in different data centers. So that goes off of what we talked about in the previous section. Same idea here. These could be in different availability zones. So I'm going to erase this and do a quick summary of this. So take a mental snapshot. Remember how beautiful my US drawing is. So let's make a little diagram showing the flow of a request. We have the client making a request. I'm imagining this to be a web page requesting data from an API. This is going to use some kind of geolocation-based DNS. And this will be the way that we know which section to direct to. And this is the step where the client is given one of the regions, maybe that's West Coast, maybe that's East Coast, based on the location of the client. So you would set this up at the DNS level. So for example, in Route 53, and there are various techniques to doing that. Maybe that's something we can get into in more detail in the future. But for now, we're just going to kind of assume this level works. We need some way to direct to the appropriate region. This will be especially important once we move to multiple continents, because we don't want to be sending people from Europe all the way to the US or from US all the way to Europe because of that latency. So this is an important step. We're just going to kind of gloss over for right now. Assume that works. So this is going to direct it, in this case, one of 2 different ways. We have region 1, and then we have region 2. You can think of this step kind of as a load balancer for cross region. But within a single region, this is where we'll actually have a load balancer. Same thing over here. Most likely if we have multiple servers in one region. So that's going to be a single endpoint that is hit when the client is routed to that region. And this is going to route to, let's say, 3 different servers on this side. And just to show that it doesn't have to be the same all of the time, we could say we have 2 servers over on this side. We can scale them independently. So you can horizontally scale independently, meaning adding more servers on one side than the other, and you could vertically scale independently as well. So you could increase the size of one individual server if you needed for some reason, which you probably don't need to do if you're going to be horizontally scaling, but just so you are aware that that's possible. So this is one way to do it, but if you also include the split across multiple availability zones, it's going to look a little bit different. So it might look like this, where we have availability zone A, availability zone B. So it may look like this. where this availability zone has 2 servers and this availability zone has 1 server. Same idea over here. So we'll have availability zone A and availability zone B. And this one will have a server. And this one will have a server. So this is what it may look like. So one request might be routed like this. We go from the client. With DNS, it routes us to region 1, ultimately giving us this load balancer, choosing to direct us to this availability zone, and ultimately to this server. The question now is, what happens if we have some other services that this service needs to interact with? Most common one that I would think of here would be a database. So let's say we have a database here, and this API server needs to read data from the database. So it's going to make a request to the database, and every server might need to do that. So if we're over here, we might also need to make a request from that database. So we basically did all this fancy pants routing, but then we ultimately have to make a request to another server, which this line here might introduce a substantial amount of latency. If we route somebody through to a West Coast server, and then that West Coast server has to make a request back to an East Coast database, then it defeats the purpose of sending them to the West Coast server in the first place. We could just have everything over in the East Coast, and we wouldn't have to worry about all this multiple region garbage. We could just keep it simple. So all that to say is, as you spread things out, it introduces new complexities because now you have to think about all the other services that this service interacts with. Let's say this request is 100 milliseconds, and this one is 200 milliseconds. And now let's say we sent that same client over to the East Coast, and through this process, it takes 200 milliseconds. But then the database request, because it's closer to the server, takes 100 milliseconds. The total time here is the same. So if you look at these add up to 300, and these add up to 300. So it wouldn't really matter if we directed the person on the West Coast to the West Coast server or to the East Coast server, because it's just going to adjust the numbers between the API layer and the database layer, ultimately giving us roughly the same value. Now I know there's a lot going on here and I'm almost done, so we'll clear this off in a second, but I wanted to mention 2 potential fixes for this that we're really going to explore in much more detail in upcoming lessons. One way to address this latency concern is to have a multi-primary database or multi-master, multi-write database, where not only do you have the database over here, but it's connected to another instance over here. This could potentially be much closer to this server. So instead of directing the traffic up that way, we could direct it up this way, reducing that latency from 200 to, let's say, 100, improving the overall performance for that request. That's one potential fix. So I'll just write these up here. So having multiple write nodes in your database. Now the next possible solution, or at least improvement here, would be a little bit simpler, especially if you're working with like Postgres or other relational databases. You could just have read replicas. So in the case of read replicas, you'll still have this database instance here, but it will be limited to just reading. Wow, this is getting insane. But that's going to at least improve much of the performance of the app. It's often the case that we do majority reading. So in the case of social media, most of the time you're reading the feed, you're not writing posts as much as you're reading posts. So that's one way we can improve it as well. And it's simpler than having multiple write nodes, but we are going to, again, get into databases in much detail in one of the upcoming lessons. I've been saying that for multiple lessons now, but we're building and building and building. We're almost there. So keep that in mind. We're going to address this in a future video in much more detail. A third one, which I'm not going to draw much for, would be caching. So specifically I said specifically, like I had something specific in mind, then my brain was like, duh. So with caching, there's a bunch of different caching levels we could talk about. We've talked about them some when we were talking about scaling an app to millions of users. But here are some examples. We could completely cache pages, so we don't even have to make a request to the API. We could cache certain things in the database in a local cache, which is much closer to the server, so in the same region. In that situation, instead of reading from the database, you would read from the cache. And then you would only need to hit the database if you didn't find the information you were looking for. All right, I'm going to erase this before I throw up, and we're going to do a quick summary of what we just talked about. So we just talked about splitting an app across multiple regions It definitely increases the complexity, as you probably can tell from our previous diagram, but it's still a way that you can improve latency. This will also help us with high availability. Now the chances of something going wrong that affects multiple regions, man, that's bad. So we definitely have higher availability, and we can definitely scale the app more. So scalability. Now let's talk about a few concerns. The complexity, which includes setting this up, as well as communication between services that are in different regions, such as if you have a database you have to access that's in a different region. Always draw upward. It drives me crazy. And potentially this will be higher costs. So if you're in a scenario where you're ever transferring data between regions, you might be charged for the movement of that data. You can do additional research on that if that's something you might be doing, but the idea is that as you spread things out, there is a cost to moving things that you'll need to account for. And here's just something to consider, which is this still might not be global. The ideas we talked about are pretty much going to be the same when we're working with regions that are outside of North America, for example. But if you start running servers from other countries or other continents, there are a few other concerns you need to be aware of, and that's what we're going to talk about next. So we've talked about 3 different deployment options when it comes to bringing your app global. The first being just everything within the same data center, pretty limiting. The next, splitting across data centers but within the same region. Then splitting things up to different regions. And now we're going to talk about splitting things up into different continents. Now the regions are often grouped by continent, but some of the concerns I want to talk about are going to be at a country level potentially. So specifically, this has to do with user information, privacy, and different rules for different countries. So if we want to take an app global, we have to worry about local concerns. So whatever the localization requirements might be. And this is going to depend a lot on the type of app you're building. And I'm definitely not going to cover this topic adequately. You will need to do as much research as you can if you're going to be storing data in different countries and you're going to be building an app that works across multiple countries where you have servers running in different countries. Working with 2 regions in the US is probably going to be treated the same legally, but if you have a region in Europe, that's going to be different than in the US. I'll go through a couple of quick examples. In the US, there's something known as CUI, which is information that's not classified but still sensitive. That's probably something you don't want to be storing in servers in other continents. I don't know the ins and outs of the laws for that, and that's just one example of data, but if you were working with classified information, for example, then yeah, that's probably even going to be more strict on where it can be stored. I think different cloud providers might even have specialized instances for certain types of data. So within the US, you might be able to get a server that has some additional restrictions, but I think AWS has some Gov Cloud instances or something that might be more compliant for certain rules or laws, so you can look into that. It's going to be pretty similar for European data, so GDPR or health records of people in Europe, that might be something that you have to keep physically located in Europe. Again, I know I've said this, but I'm not an expert on any of this stuff. I just wanted to bring it up to make you aware of it. I feel like if I left this out, it wouldn't be complete, but it's something that's really specific for the type of application you're building and what countries you're going to be servicing. You can imagine if a large percentage of your user base is from, say, China, maybe there are some certain laws you have to adhere to depending on what type of data you're storing. So the 2 biggest things to think about when it comes to going to different continents, the first are the potential latency improvements, especially if all of the services that your request is going to hit are in that region. So if you're using some kind of global database like DynamoDB global tables where you can write and read from multiple regions, that's going to drastically improve the performance because the latency is going to go down a lot. Consider making a request over the internet from Europe to the US. That's going to take a lot longer than if you could keep everything just in Europe for a European user. And then the other thing to concern yourself with are any local laws for where you're storing data or the users that are accessing your services. Now there's a concept, multi-region failover. So let's say you had 2 regions and these were pretty far apart because you're working on improving latency for users, but say something goes wrong, this region is not working. You can direct everybody down to the other region. So not just people who are local, but people that are far away. This really does go back to the GeoDNS stuff that we were talking about, but just wanted to let you know that it's not something where one region's going to go down and 50% of your users can't use your app. If there are no concerns about localized laws or whatever, there's a good chance you can just direct traffic over to another region, and that can often be set up to happen automatically, so you have a very resilient service. Now, I wanted to talk briefly about CDNs. Again, this might be some review from the previous videos, but I wanted to talk about them within this context as they can help us achieve similar results to routing based off of geolocation. So this is basically going to put your content on a bunch of edge servers across the world. So this goes back to what we were talking about with caching. This is another form where if somebody makes a request from right there, they will probably hit that edge server. Whereas if somebody makes a request from right here, they might hit that edge server. So it's kind of like a little hack so that you can get some of those benefits of being global without having to have such a complex architecture. Now, typically, these are for static files. So HTML, CSS, JavaScript, images, videos, those kinds of things, that's where CDNs shine. However, because of the focus on the static content, it might be more limited than having a server in different locations. That's CDNs in general, but there may be some variations. So potentially you could cache responses from APIs. That would also improve the app performance. Then it's kind of like you have a distributed server, but really it's just a snapshot of a very recent response. So if you have data that you're retrieving that doesn't update very frequently, you could potentially cache that response, making things faster across the world. Or something that is a little bit different than this traditional CDN idea are edge workers. So you could imagine each one of these being a server that can do computation. So if there's a way we can basically distribute our API layer across many edge servers, in this scenario, we could have a true backend that's distributed across the world. If you're interested in learning more about this idea, you can research Cloudflare workers. Most likely adding a CDN is going to be a step you would do fairly early on in your app deployment process. I would probably do this almost first thing because it's going to immediately improve the performance for users across the world. And often there are other benefits packaged with it, such as security and DDoS protection and SEO benefits. Cool, so that's a summary of the CDN layer. Perhaps that's something we'll do a dedicated video to. All the ins and outs of CDNs and how they work, what you can cache, what you can't cache, how caching works. Maybe that's interesting. If so, let me know and maybe we'll do a video on it. Now, when it comes to scaling databases, that's what the next section of videos is really going to be about. So we'll talk about some general database concepts, so the CAP theorem and other things like that. And that's going to build the foundation for us to understand the different types of databases that exist, when you might want to choose one over the other, and all of the ins and outs when it comes to scaling the app to support more and more users. So I would encourage you to leave this video with the intention of following up with the next video so you can continue your studies. There's a lot of information, but it's fun, it's cool. We get to draw on a chalkboard. In what other scenarios do you get to draw cute boxes and arrows and call it studying? So let's stick with it. Stay tuned for the next lesson. We will talk about database stuff, and I'm sure it'll be a great time. Thank you so much for watching this video. As a reminder, I'll have links to resources down below, which will include the backend engineer mind map and the link to the mentorship program if you want to take it up a notch when it comes to your career and your ability to pick up this information. Thank you so much for watching, and I'll see you in the next ones.